I noticed I started every one of these things off by saying, okay. Did you notice that?
Yeah.
I gotta stop doing that. It's irritating.
Yeah, just say something else
Okay.
like bonsai.
Banzai!
Is it recording?
Yes, it is. Okay. If the ball falls off the table, how long until it hits the floor? So we know a situation like this, and then the ball comes off boop, and hits the floor down here. So this height right here, if we have that height, what else do we know about a ball falling off the table? Okay, we could do that. We could do like potential energy, kinetic energy if we wanted. Think like, think of the equations that relate to energy. Do any of them have to do with time? No. So we could use PE equals KE, right, and get MGH equals 1/2 MV squared. Cancel that and get V as the square root of 2GH. So now we know V final. We know V initial is 0, right? And we know X. What it was the height of the table? Wasn't it like 1 meter? Yeah, X. So then we need to get time, right? So if we want that, we can use, before we did this thing where we said average velocity is X over T, and it's V plus V final, V plus V0 over 2. Do you remember this? This gave us an equation that came out to be X equals 1/2 V plus V0 times T. And then from this, we could find time, right? We could say time is equal to 2x over V plus V0. So then that allows us to come up with 2x. Since V0 is 0, it's 2x over the square root of 2GH.
So is that how you wanted us to do that one?
Isn't there an equation for that, like on the formula sheet? Just velocity.
Velocity and, well, I don't think there's any equation in your formula sheet that has velocity, distance, and time.
Does that say x equals 1/2 v plus v0 times c?
X equals 1/2, yeah.
What's t equals to 2x over v plus?
That's this equation solved for T.
So is it v plus?
V plus V0, and then I crossed out V0. So then this becomes 2 over the square root of basically like, wait, is it 1 meter? Is that right?
Yeah.
So it's basically 2 over the square root of 20. The square root of 20 is 2 square root of 5. So it's 1 over, the answer is 1. And I don't know what that is off the top of my head. 0.45 seconds. Oh, shit. That's how long it takes to fall 1 meter. 1.4 seconds. So anyways, that's the time. And then if the toy is reloaded and is held horizontally when fired, how far does the ball travel? In part B, what was the initial velocity in the x direction? From part B, what was it? 1.61? So 1.61 meters per second. Well, so it's traveling. This ball has a horizontal velocity of 1.61 meters per second. And if it falls for 0.45 seconds, do you see how I find the distance? Because x is equal to vt, right? So then I just take 1.61 times 0.45, which is going to give you like 0.7 something. Multiply it out. Something like that. What do you get?
0.5 like half, right?
Yeah,
That,
would be 0.8. So I'm guessing, so 10% less than half point. So 0.72 maybe? 0.72?
Yep.
And there's your answer, 0.72 meters. C.
Honestly, I was like,
Okay, so then I get 1.37. So the result is it goes farther.
We have to repeat the top part for now that you're recording.
Oh, yeah. So what we did, we took this V from part B. I guess I should do this so you can see. So we took this part B, and then we plugged in the 2 for the for doubling the spring constant. We got velocity, multiplied it by the time it took, which is still 0.45 seconds, and that gives us a new distance from the edge of the table.
So use the time for part C.
Yeah, because the table didn't